Okay, welcome to this Burns revision. Part 3 is motion graphs and acceleration as part of the mechanics module 2 topic. First of all, we'll look at velocity, the definitions. The velocity is the rate at which the displacement changes. Okay, so the rate at which the displacement changes, and that's given by the equation v equals delta displacement over delta t. The displacement is meters, the time is in seconds, so velocity is meters per second. Acceleration is the rate at which the velocity changes. So the rate at which the velocity changes, the equation for that is acceleration equals delta v over delta t. Now, the units of v, change in v is meters per second divided by seconds, so the acceleration is meters per second squared. Now remember, deceleration is just negative acceleration. Okay, the first thing we'll look at graph-wise is a displacement time graph. Okay, so displacement on the y-axis, time on the x-axis. We'll just use meters and seconds here. Now a straight horizontal line, a diagonal line represents the constant velocity. A straight diagonal line, but steeper this time, is still constant velocity, but it just tells us it's travelling faster than before. Okay, if it then curves off like so, the gradient's getting less, so that tells us it's decelerating, and that's because the gradient equals the velocity. So steep graph means high velocity, shallow graph means smaller velocity. So when it curves like before, it's deceleration. If it curves where the gradient's getting higher, that means the velocity is getting faster, so that's acceleration, and then a horizontal object is stationary. Velocity time graphs. Okay, so time goes along the x-axis, velocity goes up the y-axis, and again a straight diagonal line. This tells us the velocity is increasing at a steady rate, so it's constant acceleration. If it was curved like that, that tells us it's accelerating, but it's non-constant acceleration because the gradient is getting steeper. A flat, straight line, horizontal line, tells us it's constant velocity. And that's because the gradient of the line is equal to the change in y over change in x, which is change in velocity over time, which is the acceleration. So this gradient is just the acceleration. And the steeper the line, the greater the acceleration. Shallower line, the smaller the acceleration. Negative acceleration is deceleration. So if you've got a graph with a negative gradient, that tells us it's decelerating. And the final thing is the area under a velocity time graph gives us the distance travelled. Now another part of this is when you're considering falling objects. Okay, so objects falling due to gravity. Now let's just consider a ball bearing. Ball bearing initially accelerates because it's only got the weight acting downwards, so it accelerates in that direction. F equals ma if you want to work that out. The second, quite quickly though, that acceleration decreases because as it accelerates, the air resistance, the resistive force increases. So as the velocity increases, the air resistance increases, so the resultant force decreases, causing less acceleration. And eventually it'll reach a point where it hits terminal velocity, and that's when the downward force equals the upward force, so the weight is balanced out by the air resistance. Okay, so now if we plot a velocity time graph here, what we end up with is a nice curve like so, where the gradient is at its maximum at the beginning, because that's when the acceleration is at its greatest. Then the acceleration decreases as the air resistance builds up, and then finally you reach terminal velocity where it's a flat horizontal line. Okay, 2 past paper questions to try. First of all this one, question 1 June 07, and then second of all question 4 January 2005. Have fun!